This video is on managing BGP sessions. So it's already been said that BGP handles very large volumes of routing data. If you have full internet routes, you could have upwards of 500,000 routes or more. When you put a policy change in place with BGP in order to, let's say, filter or alter some attributes, those changes do take effect immediately, but depending on the nature of them, it will only be applied as the routes are being brought into BGP or being sent out of BGP. So as a result, it could take some time before the updates that you've made, for example, to policy, have any impact whatsoever to the BGP paths. So if you would like to see the changes applied immediately, then you must trigger an update and force the router to either receive all updates again or send them out again in order for these to pass through the filters. So the three major ways in which you can trigger an update are to do a hard reset, a soft reset, or what's called a route refresh. So our hard reset we've actually looked at already briefly before. As was mentioned, if you do a clear IP BGP star, then this takes down all your BGP connections with every peer and forces them to be relearned. Everything that was previously in the table will have been discarded, such that as the new routes are being learned, then they'll pass through the filters, and every session, of course, then must transition from being idle all the way to established. And then after being established, the updates will flow properly. Now, with a hard reset of every session, of course, that can be significant, especially if you have multiple neighbors. So one way to tackle just one neighbor at a time, and that reduces, by the way, the resource usage, and it also allows you to selectively refresh from one neighbor. So this is where the second construction comes in, clear IP BGP, just specifying a neighbor address. That'll target a single neighbor. Another way to do it is via a soft reset. Now this is a soft reset outbound. What this does is resend all your BGP information to the neighbor, but it doesn't reset your TCP connection. It doesn't reset your peering. So your connection remains established, and this allows you to refresh based on changed outbound policies. The last way is called inbound soft reset, or sometimes known as route refresh. And actually there's two different ways to do this, but to affect inbound policies or inbound table entries, you can specify this first command, which specifies to iOS that it should set aside some memory to store all the updates from this neighbor. And if you do this and then later use the clear IP BGP soft in against this neighbor, then this will use the stored information from memory to regenerate your updates filtered properly with your inbound rules, your policies. However, if you haven't done this previously in the config-router context, then you won't be able to do this. The route refresh, without having it stored in memory, is supported by later versions of iOS, and in this particular case the routes are re-advertised and without having to be reprocessed from memory like we saw in the previous slide. Again, the connection remains established. Now, the word of warning on this, of course, is that the neighbor has to support this. This is why it's noted here. It was introduced in the later iOSs. If you're wondering if the neighbor supports it, one way to do that is to use the show IP BGP neighbors command, and in the output that you receive from that command, there'll be a line that says received route refresh capability from peer. So it'll show that that peer has the capability to do this. This next slide shows you what you can see from the debug IP BGP updates command. This actually is command output. It's a partial output because some output has been omitted from this router A after a clear IB BGP command was issued against neighbor 10.1.0.2. So you see here the clear IP BGP, and then there's some output missing, but just highlighting a few things here. The first update that's highlighted is an update to 10.1.1.0/24, and it shows you the change. This is where actually router A is sending an update out to the neighbor, and this next hop is router A itself. Down here it's sending a different update for 10.97.97.0/24, and notice this next hop is not itself, but it's this is the next hop that was carried through from the external BGP. We'll talk more about this later, but just trying to show you that you can actually see the updates going across if you do a debug. Down further, again there's some more output omitted here, but down further you can see that you've got some received updates now from that neighbor. So notice it's received from 10.1.0.2. That's the neighbor. And this update is showing you've got paths to 10.1.2.0 and 10.1.0.0/24.